Hi, everyone. Today is Tuesday, October 30th, 2018. This is the weekly meeting for Kubernetes Sig Docs. Hello. Happy Halloween if you are US adjacent or just like US holidays. Hope everyone's doing fun stuff tomorrow. And while we're on the topic of scary things, let's talk about the state of our content. But first, let's introduce new contributors. I see someone named Tiger. That's maybe the best name we've had in here in a long time. So hello, Tiger. Not a lot I thought I'd be saying in a Sig Docs meeting.
That's just a conference room name. I'm actually Sam. I'm at Heptio. I'm just lurking.
Well, welcome, Sam at Heptio. Really good to have you here. Let's see, Sam at Heptio. Cool. Thanks for joining us. Updates and reminders. Our PR Wrangler this week is Cody Clark, who is here to give us a double shot of PR wrangling. Cody is really close to being at the threshold for PRs for an approver, and I figure 2 weeks of wrangling PRs will give Cody all the comfort and then some to be able to act successfully as an approver for K-Website. So thank you, Cody. Please feel free to ask questions, but you seem like you got it pretty locked down. So any other updates or reminders before we move on to the agenda? All right. Let's see. Let's start with content. Dominic and Andrew, tell us about what the hell is a pod, anyways?
Yeah. So we put together a blog post, but I think this will be a presentation on that content, and then we'd like to get your feedback. And I think it will sort of complement the containers presentation that Steve did, I think internally, but yeah, so Steve, we would love your feedback too. Take it away, Dominic.
All right. Let me share my screen. Here we go. Just give me a quick thumbs up if you can see it. All right, cool. Thank you. So as Andrew already said, this is the presentation for the blog post we just released last week. What the hell is a pod anyways? As usually, interactive, don't be shy. If you have any questions or comments, please interrupt at any point in time. And then we jump in right with the definition of what a pod is. We decided on the definition: a pod represents a request to execute one or more containers on the same node. But colloquially, the term pod may either refer to the request or also to the set of containers that are executed in response to that request. We use the term pod when we mean the request. We will use the term container set when we actually talk about the containers that are executed in response to that request. So one important tidbit is that pods are considered the fundamental building block of Kubernetes, because all Kubernetes workloads, whether it's a deployment, a replica set, or a job, are eventually expressed in terms of pods. This is this little diagram you see here, where a deployment results in a replica set, which in turn results in pods, which return results in containers. So the important part here is that pods are the one and only objects in Kubernetes that result in the execution of containers. So one statement: no pod, no container. At that point, I would also like to add a bit of a critique to the Kubernetes IO website, where the definition states that the pod is the smallest scalable and or executable unit on Kubernetes. That is incorrect for two reasons. Number one, when you say smallest, that implies an order relationship between the other objects like deployment, replica set, and pod. That is not there, but you need the order relationship in order to say smallest. And it is actually the only scalable and executable unit on Kubernetes. So that just as a side note. So the pod in the context of Kubernetes is highlighted here in the Kubernetes architecture diagram. The pod is represented as a pod object in the Kubernetes object store. It has accompanying objects that are important for its life cycle, mainly the binding and the node object. And it is the object of interest for the scheduler and the kubelet. Here we got the diagram that reflects the data structure of a pod, the binding and the node. This is indeed a reflection of the Golang data structures. So the pod in its pod spec specifies the containers that are to be executed and the desired restart policy in case of a container failure, and in pod status tracks the status of the pod's execution. A binding object then binds a pod object to a node object. That is, it assigns a pod to a node for subsequent execution, and a node object just represents a node in the Kubernetes cluster. The Kubernetes processes a pod mainly in two steps after it is being created. The scheduler schedules the pod to a node, and the kubelet on that node is responsible for the execution of the pod. The Kubernetes scheduler is a classical Kubernetes controller in the sense of conceptually following the control loop. The task of the Kubernetes scheduler is to schedule the pod, that is to assign an appropriate and assign an appropriate node in the Kubernetes cluster for execution. That is obviously a in itself complex task. Yeah? The scheduler is a policy-rich component that takes lots of constraints into account, yet the end result is the same. It finds a node and binds the node to the pod, or just keeps trying. The kubelet also follows conceptually follows the control loop pattern. The task of the kubelet is to execute the pod. That is, it executes the container set of the pod. And the kubelet executes a pod in two phases, the initialization phase and the main phase. During the initialization phase, the kubelet sequentially executes containers according to the init container specification in order they are specified in the list. And during the main phase, the kubelet concurrently executes containers according to the pod's containers specification. The execution highlighted here, the execution of both cases follows the same process. It will call the create and run action on the CRI, the container runtime interface, mapping that to whatever container engine you're actually using, for example, Docker, waiting for the terminate event. And in case of termination, the kubelet will apply a restart policy. The restart policy is one of always, on failure, and never. It is a pod-wide setting, not a container-wide setting. However, it does have different execution semantics for the init phase and the main phase. The containers in the init phase are supposed to be executed to completion. that is whether the restart policy is always or on failure, both map to the same behavior, that is, if a container fails, it will be restarted. However, if it terminates successfully, it will not be restarted. That is different from the main phase, where always also restarts a container, even if that container exited successfully.
Hey, Dominic, should we talk briefly about the difference between an init container and a main container?
We can. So the difference is basically not there. So the specification of a container or of an init container and main container is the same. So the kubelet assigns, well, the pod / and or kubelet assigns the semantics to init and main containers. Init container, as I said, are meant to run to completion. They are used, for example, for preparing the directory structure and files, any initialization tasks that are then necessary for the main containers to run successfully. And the main container is basically the most important, even so that is not necessarily a strict definition, but it's what we usually think as the most important container in the pod. And also, sometimes as an interesting tidbit, when we say pod, we refer to the container set, but sometimes more specifically to the main containers, or even more specifically to the most important container. Oftentimes in our mind, there is a one-to-one mapping of the pod to its most important container, but that is strictly speaking inaccurate, but colloquially speaking, that is what happens.
What is the definition of main container? I really missed in that. That's I mean, if I looked at a YAML specification, how would I know what the main container is?
I do not have the YAML here, but I have the data structure here that basically also encodes the YAML. So the pod spec of the pod actually has two, and in YAML you would see there's two different sections. One section is called init containers, and the other section is plainly called containers.
Yeah, so the main containers are just what you normally think of as containers. It's anything that's not the init containers, right? They're the ones that are run concurrently when you're executing the pod. The init containers are just run in the beginning to initialize the pod, but people usually don't think about those.
Okay, so they're like hidden containers.
It's a little more than that, Andrew, I think, because even after the init containers have finished, you could have two containers that run continuously, and one of them might be considered to be doing the main job, and the other might be doing some side task. In fact, they're sometimes even called sidecar containers.
But you could have like 4 main containers, right? I mean, you put a pod and you group containers together to do different things, and you could have different specifications in there, correct?
Yeah, so the way I like to think about it is strictly on execution semantics. That is, the init container runs sequentially one by one. And the containers, it is just called containers, but to differentiate, I call it main containers. The main containers are run concurrently. Now, how you use all of this is completely up to you.
So Dominic, I see a question in chat from Sylvie, who is asked, should we add sidecar containers or describe that a main container might be an app or a sidecar?
It is a fairly typical use case that is also also heavily used, for example, in Istio, the sidecar containers. It is actually a good idea to introduce a short, like a paragraph mentioned sentence of how the main containers, how multiple main containers may be used. But just one word of caution, right? The pod and the execution semantics do not tell you at all how to use these containers, right? Some patterns emerge, sidecar, very popular pattern. Init containers to prep the volume, so the directories and files, very popular pattern. However, Kubernetes does not dictate, or the pod does not dictate at all, how the individual containers needs to be used.
Dominic, Brad also has, Brad, go for it.
Yeah, so when you did your initial definition of the pod, what popped in my head is it didn't capture a lot of the key features of what I think about when I think pod, namely the containers inside the pod, there's a single IP address.
Mhm.
They are able to communicate via IPC, and they share a port space.
Mhm.
And there's also the sort of the higher level concept of you put containers in a pod because they're probably related and need to run on the same node. So from what I recall of your definition was like, oh, these are containers on a node. It didn't seem like all those key critical features when I think of what a pod is were captured by your definition.
That is correct. So the blog post states shortly that in addition to this definition, that pods share resources like, for example, volumes and network stacks.
Sure.
And it is correct. This is an important feature of a pod. I have been mulling my head for quite a while, and eventually came to the conclusion that I don't think that these properties are properties of the definition, but properties of the implementation. So you are absolutely right. The containers in the pod share these characteristics, right? Like shared volume, shared network spaces. But I didn't count it towards the definition of a pod, but it is basically a property of a pod, an implementation decision of Kubernetes.
Yeah, I mean, as long as your blog post captures those key critical features, because again, the end result is not to have an elegant model. The end results have an elegant model that also properly captures all that you want to capture so that somebody can take away a really solid understanding of what a pod is. So as long as you cover it somehow, maybe out of bandwidth from the model, that's fine. But I mean, you just want to make sure those key things don't get lost.
Yes, absolutely correct. However, the blog post does defer the description of, for example, volumes and networks to a later blog post.
Mm-hmm.
But it is mentioned.
I think when we work this back into the Kubernetes.io docs, we'll have a section about the properties of the pod, which go into detail about those things.
Yeah.
Sure.
I was just going to ask Andrew, going back to the this definition of a pod, the distinction that you make, Dominic, between the request and the container set. I wonder whether that's a distinction that we currently use meaningfully and consistently throughout our docs, or whether that's something that we'll have to update in the scope of adding this modeling in. Andrew, do you?
Yeah. So far, this distinction is not made in the documentation. However, I do believe that the distinction is an important one because the request is what gives the pod the identity, not the container set. If I submit an identical, two identical pods, basically two identical requests, they may very well result in two different container sets being executed due to failures and restart policies. That is why for the same pod, like semantically equal pod, for the same pod, two different container sets may emerge over time. So the container set is not a great like identifying property of a pod. That's why the pod is mostly defined as a request.
Awesome, thank you.
Yeah, because the container set is sort of the consequence of the request, and a lot of stuff that you need to deal with is in the request. So like if everybody's kind of mental models are on like the result, like the executed containers on the node, it's sort of missing a lot of area where they need to understand what's going on.
Right. No, this is awesome because that is exactly the mental model that I had. So this is great to clear that up.
Okay, let me chime in here. I'm not yet convinced. I'll have to look at this a little deeper, but I'm not sure this level of depth is what we really need to convey to our readers. My first thought is it's probably more helpful to convey the idea that a pod is a set of containers that share a network namespace and an IPC namespace. And I kind of think that should be in the definition because all pods have that feature. Not all pods share volumes, so I can see why we wouldn't put that in the definition. We'd put it later as a property that a pod can have. But I'll look at this more deeply, but that's my first impression is this might be getting a little too deep for our readers. We might just want to get back to it's a collection of containers that are related in this way through these namespaces.
Yeah, I think Steve articulated my point more eloquently than I did, but I gotta say I agree 1,000% with what he just said.
So it is true. This is a very detailed description, and if you later have a look at the blog post, here I actually left out quite some information, like for example, formal description, formal models of how pod and binding objects and node objects relate to each other. Also, later on, you will see, or actually not see in the presentation, but in the blog post, the formal definitions on how the phases, pending, running, successful, failure, are actually rolled up. So whether you wanna go to that level of detail in the documentation, of course, is absolutely up to you. But it is definitely true that this material is not a beginner's material, right? It is aimed to really tell you everything you need or everything you could know, everything about the nature of the pod. Whether you need to know that by just using a pod or even just a replica set or deployment is a different question. But this states the nature of the pod only. If you want that level of detail and documentation, or more focus on how do you use it instead of what it really is totally fair. It's a totally fair discussion.
Yeah, because I think we're going to have to decide how to split up the material. Like, to me, this is our source material that we can use, but then we have to figure out, what is appropriate for like the novice users that are onboarding, and then what we need also more intermediate and advanced material as well for people that want to understand it more in depth. So I don't think we necessarily have to stick this all in the same topic, document in Kubernetes.io, but I think it's good to have it and have it on the site somewhere so people can look more, more in depth into what, how a pod functions.
So I'm way more flexible on what goes into the blog post because I think it's an incredibly interesting exercise to look and investigate the modeling and see what can be ascertained from the modeling and put it together. To me, that's at least a separate discussion from what should go in the docs. I think I'd love to see the blog post first, and very cool about the model and what we put in there, and then look at that and then decide as a separate discussion, well, what is appropriate to go in the docs and won't confuse folks. Steve, were you thinking the same way? Because I'm totally cool with it being a blog post. It's very interesting and instructional, but then I think there's a difference between what goes in the docs because you got to be a little careful. You can really confuse folks. Does that make any sense?
That sounds fine to me too. Yeah.
Any other questions at that point that I missed?
Sylvie mentioned in the chat that this is helpful for onboarding code contributors.
I would agree with that. I think as the model gets refined, I'm learning a little more about the internals than I would have known. And so from that perspective, I find the model really, really helpful and instructive to go deeper on the models. I mean, so I kind of agree with that conversation as well.
Cool.
I'm thinking that it is useful for docs contributors as well, even if at this point, I'm inclined to agree with Steve's comments, but with a stress on, I'm not sure, right? How useful this level of content is. I mean, our audience for the docs, for people who are trying to get clusters up and running, not necessarily contribute to the code unless like driven to it by desperation or whatever, or the lure of a GitHub contribution graph. Anyway, because the audience for the Kubernetes docs is so broad, and because we are concerned with onboarding docs, maybe directly this isn't stuff that we as maintainers are going to focus on or worry about delivering in detail. But I am finding it tremendously useful for thinking about how to revise the current content, how to shift the focus. I'm at least finding the pattern of thinking in terms of resources hugely useful, even though I'm also finally learning some of the very profound differences between gRPC and CRUD over HTTP, which I refuse to call REST. I mean, it can be, but it isn't by definition. I mean, that's not stuff that belongs in the Kubernetes documentation either, but understanding those things helps me understand how a cluster works in ways that help me assess docs contributions and help me think about improvements I might make on my own. Did that make sense? So I see this as a tool for us too, as well as a potential tool for some perhaps smaller subset of our audience.
Yeah, my hope for this project was that it's sort of a Rosetta Stone to get like the engineers and the tech writers on the same page. And then, we can then decide how to present it to the users. But then at least like we as the writers have a firm understanding and can be more, authoritative about like when we're writing the content.
I would just add, as I said, the docs are obviously this is in your ballpark, but I would just caution is like I understand that a high level of detail is sometimes uncomfortable, and right now I only have anecdotal evidence by browsing the issues on the GitHub Kubernetes repository. But there are quite some issues where people either file bugs or have questions because they do not possess the correct mental model to assess that the behavior that Kubernetes is actually displaying is by design, right? So they do have trouble assessing or reason about the behavior Kubernetes shows, and then file bugs or questions as GitHub issues. And then some of the engineers usually jump in, sometimes reply with a few lines of code or with a link to the source file and with an ad hoc explanation of why this behavior is the correct behavior, which points in the direction that they do not have the tools to reason about the actual behavior of Kubernetes.
So everything that I'm hearing is pointing to not whether the material is suitable for the documentation, just how to implement it and how to implement it sensibly as an introduction, as an intermediate step, and then for advanced knowledge. But ultimately, that comes down to, like Andrew said, our ability to authoritatively understand and communicate and make decisions based on a better and more thorough understanding. And refactor content based on a deeper level of knowledge all around from docs contributors. Because Dominic's absolutely right. I see the same thing in our issue log of questions about function that aren't transparent in our documentation. Engineers who will respond, and that's great for that one person who had that question, but no preservation of that log or of that chatter exchange for the wider documentation. So, I'm super excited about this. I think it's awesome. I think we will, to Brad and Steve's point, have to be judicious about how to introduce the material in stages. But that's what we do. So,
and let me use an analogy. Probably limps a little bit, but still. So this is definitely not material in the sense of teaching somebody to drive. As they put the key in the ignition and turn it, and if it starts, it starts. This is more material of quality of, all right, let's take the car apart piece by piece and then put it together piece by piece. Is it necessary for the one who needs to drive? No. Is it helpful if things don't go right? Yes. If you put in the key in the ignition, turn it, and the car just does whoa, 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 whoa. If you know that is a battery, you know what to do next, right? And that is then somewhere in the middle of the spectrum. However, that also brings us to the thing. A lot of this level of detail is helpful if Kubernetes doesn't behave like you think it should behave, right? If Kubernetes is happily doing what you ask it to do, you probably don't need to know. So for this slide that is shared right now, that shows a example execution timeline of a pod with 2 init containers and 2 main containers. You see the init containers are executed sequentially, and they have to terminate successfully, otherwise the pod will not continue. I'm sorry, otherwise Kubernetes will not continue to execute the containers in the pod. In this case, you also see that the main container 1.1 experiences a failure, illustrated by the red dot, and is then, because of the restart policy on failure, is restarted. That actually brings us to another tidbit in Kubernetes. We say a lot that a container is restarted. This very much depends on the definition of restart. The container, by the identity of the container, is never restarted, right? Kubelet does not restart a container. Kubelet creates a new container according to the same specification. If this is what is defined as restart, then the term restart is correct. Since it is not strictly defined, it actually may spark the wrong mental model. And this is also when the container set does actually not match one-to-one to the specification, since in the specification and the container status, you have actually one container, the main container 1, yet during the execution, you have 2 of these containers. They are never active at the same time, but they can be active sequentially, and there is more than one. That is breaks the one-to-one relationship. Now, during the execution, right, the kubelet reads the specification for the containers, communicates with the container runtime, and has the container runtime execute the containers on its behalf. But of course, it also takes into account the current status of the containers and updates the status of the pod accordingly. Here and in the blog post, we are only looking at the most high-level roll-up, the pod phase. There are also multiple pod conditions that the pod goes through its lifetime. That is not illustrated here or in the blog post. The pod phases are pending, running, success, and failure. And their definition of what pending actually means or what running actually means, the formal definition can be found in the blog post. For example, running means that all init containers are terminated successfully, and at least one of the main containers already started execution, but not necessarily all of them. And last but not least, at the end of a long, hard day, we have the Kubernetes pod garbage collector, another controller, another Kubernetes controller. This one is responsible for deleting the Kubernetes object store. It takes only terminated pods into account, and after a certain time span will remove that object from the Kubernetes object store. Why after a certain time span? That is because a terminated pod also acts as a tombstone for other entities in the system. Like, for example, a Kubernetes job needs to know that a pod terminated successfully, otherwise it will recreate, reschedule, re-execute that pod. that is why there is a time span in there, so that the job gets a chance to look at the pod it started, check out its termination status, checks out success, and then records its own success in its own object status field. And after this time span, then the Kubernetes the pod garbage collector controller goes ahead, assumes that all the necessary objects had a chance to look at the tombstone, and will then basically remove the object, therefore removing the tombstone from the system. And that basically is the day of a life in a pod.
Thank you very much.
I should also mention, we're looking, Dominic, you didn't mention the unknown state, which is one of the things we're looking into. Like yesterday, we just interviewed Don Chen, one of the engineers on Node, and we're trying to find out more about like what Kubernetes does in that state. So we're hoping to have a blog post later on that's called like the unknown. But right now, yeah, we mention it in the blog, in the pod blog post, but we will go more in depth into it later.
The unknown state is the most uncomfortable state any Kubernetes object can be in, because Kubernetes cannot take action on.
Dominic, I am so sorry. I am going to interrupt just because we have gone over time for the content that.
Oh, absolutely.
For the time that we've got here. So this is a fascinating discussion. I would recommend continuing this discussion in the Sig Docs Slack channel. Let's move on. And thank you very much, Dominic and Andrew, for that. That was really good content and really discussion that came from it. So thank you.
Thank you.
I want to touch briefly on GitHub project cleanup. We talked about this in the APAC Friendly Time meeting last week, but just to review, for K website, the repository, Steve Perry went in and did cleanup, and right now there are 2 projects in the K website repository, and I think it's a good idea to keep only 2. Right now we have a project for work in progress, and we have a project for doc sprints. And for work in progress, I think if we can automate those triage columns, we can we can start moving from there towards an automated model of the work that we agree to prioritize as a SIG for content. There's more to discuss here, obviously, but I want to simply note that the cleanup work for projects is done, and we can move next week into talking about what we want the specifics of prioritizing content and tracking it to look like. So let's revisit this next week and talk more about projects. I know Steve mentioned that his power might die, otherwise we might devote a little time, but let's talk next week about what the specifics of projects can look like, and refer to the Kubernetes community project setup that Paris Pittman so helpfully shared with us. So next, let's talk about KubeCon and Cloud Native Con Seattle. It's December 10th through 13th. And just a quick show of hands or in chat, who's going to KubeCon in Seattle? 1, 2, 3, 4, 5, 6, 7, 8. Cool. Excellent. That gives us a decent number of folks. So let's see. As sort of unbelievable as it is, that's really only what, about a month and a half, less than a month and a half away, which, I mean, blows my mind about how quickly this year has gone. So when we did the Sig Docs Summit in May in Portland, we talked about doing more planning sessions at KubeCon and making setting SIG priorities as a 6-month project. I don't think that 6 months is frequently enough, to be honest. May feels like another lifetime ago. So I would like to start moving to a quarterly cadence for setting our priorities as a SIG and being intentional more frequently about the work that we agree to do so that we aren't quite so blindsided or sort of pulled around by projects that arise suddenly. And that we can also have a better sense of priorities that we can take to our respective employers and say, hey, these are the things that we agree to work on. So I mentioned that specifically because that's what I would like to spend some time doing during KubeCon Seattle, is to have like half a day where we meet specifically to discuss our priorities for the next quarter. And also get in the habit of deciding where we'll need to decide where to meet again, but start moving towards a quarterly cadence of project planning. I'd also like to do a retrospective. It feels sometimes like we don't take enough time to recognize the work that we've done. And when you think about the course of the past year, if you stop and think about it, we have done some really remarkable things this last year as a SIG. And I would like to celebrate some of the contributions that folks have made and some of the work that we've done together. We passed the 10,000 PR mark back in July. We've had multiple new approvers onboarded. I think this year we onboarded a number of new approvers that might have been equal to the total number of approvers that we had like 2 years ago. So it's yes, thank you, Jennifer. We did do some planning at Write the Docs Cincinnati, but it was less formal. So anyway, I would like the chance to celebrate and recognize the contributions that folks have made, and I would also like to think about maybe doing some awards, some lighthearted things. I think Brad will probably get the combat medal for Sig Docs service for wrangling PRs literally during a hurricane. But also things like who wrangled the most PRs over the course of the year. What is the most? Is that simply number of PRs, number of lines of PRs reviewed and wrangled? Sort of different awards and different recognitions of service. So I'd like to spend some time recognizing that the work that we've done this year has been pretty incredible, because this is a pretty incredible bunch of folks. So I guess we can talk about the specifics of what room and where, what room, what time, the logistics of our time in Seattle. Let's get those for next week. Let's see. By this next week is the 6th. Okay. All right. Greatest struggles with Black Friday Markdown Award. I don't know that that's a that's a team award, I think. All right. I think that's it for our agenda. So I noticed based on today that the content discussions, which are awesome, also tend to eat a lot of time. So I'm wondering if it might make sense next week to put more business stuff, to front load business at the beginning of the meeting, and then allocate more time to content discussion so that we don't have to worry about keeping the train on the tracks quite so much. Does that make sense to folks?
Sure.
All right, that is the end of the agenda that I have. Is there anything that folks would like to talk about in the time that we have left? All right. That's a SIG meeting.
Sure.
Thank you, everybody. Take care.